An entirely new generation of airplane is poised to move from the drawing board to flight. It's called the National Aerospace Plane, a program with the goal of providing the technologies that will allow an aircraft to take off from a conventional runway to space orbit and cruise for extended periods at hypersonic speeds within the atmosphere. The National Aerospace Plane, or NASP, Joint Program Office enlisted the help of engineering students at Virginia Tech in Blacksburg, Virginia, to design and build a NASP mockup. Under contract of NASA, the student chapters of the American Institute of Aeronautics and Astronautics and the American Society of Mechanical Engineers at Virginia Tech constructed a half-scale mock-up of the National Aerospace Plane. The mock-up was first presented to the world public at the 1989 Paris Air Show, giving people an idea of what this next generation of airplane will look like. For the 60-plus aerospace and mechanical engineering majors who signed up, the construction of the mock-up proved to be a unique challenge. A challenge similar in spirit to bringing the hypersonic plane from paper to flight. The student engineers were given overall dimensions, summarizing the major structural shape of what the aerospace plane might look like. From there, the design details were based on the mock-up construction scheme as developed by the students. The student group, under the supervision of faculty sponsors, divided into various work groups, with weekly meetings to report progress and problems. The computer-aided design, or CAD group, applied what they had learned in classes to come up with a precise design. All the construction work depended on the accuracy of this first phase. From the CAD information, templates were drawn for each 2-foot section. Precise dimensions were especially critical, as these served as the pattern for the expanded polystyrene foam sections. At the same time, the truss team was literally putting the pieces together. Here the students found that some aluminum components required minor adjustments to ensure an exact fit. Often what was needed was good old common sense and traditional hand skills. Soon the lab grew too small for the growing truss sections, which were then transported to the university hangar for assembly into one large skeleton. University shop staff provided valuable hands-on assistance when it came to the nuts and bolts of assembling this one-of-a-kind structure. Even before the truss was complete, the foam team began fitting and gluing on foam sections. Each section required a customized fit before being glued into place on the aluminum frame. Students that were most successful in the work teams became active in a leadership role, but took the time to listen to other people's concerns and points of view. Communication skills became a valuable commodity during the entire project. Through the course of the project, the original task team divisions became more fluid, with everyone pitching in as the schedule required. To cover, seal, and reinforce the foam and aluminum structure, a professional coatings team was brought in. 2 coats of I-coat, an industrial exterior coating, were applied, followed by a protective smooth sealant. The finished mock-up was first displayed at a formal rollout ceremony on the Virginia Tech campus. Speakers present included Dr. Thomas P. Rona, Assistant Science Advisor to President Bush. and Robert R. Bartholomew, Program Director of the National Aerospace Plane program. For the students, it was a proud moment. The challenge had been met. The mock-up was complete.